Welcome back to Easy Math and Circuit. In this video, we'll be looking at differentiation using the first principle. My last video talks about the basics of differentiation. If you have not seen it, you might want to watch it to know what differentiation actually entails. What do we mean by differentiation using the first principle? Differentiation using the first principle involves using algebra to find the gradient, and in other words, the slope of a curve. There are two ways I will show you on how to use the first principle to find the derivative of a function. Both ways are basically the same but with different procedures. The first way, we are just going to use simple mathematical procedures to find the slope of our function, while the second method involves using the derivative formula to find the slope of our function. Without further talks, let's see a few examples. The first example we'll be looking at is we are going to use the first principle to find the derivative of y to be x squared. The first thing we do is we introduce delta y and delta x to the corresponding sides. In the left hand side we have y, and therefore we'll be introducing delta y. So we have y plus delta y in the left hand side, and we'll be having, here we have x squared, that means we'll be having x plus delta x, everything squared in the right hand side. Wherever we see y, we replace it with y plus delta y, and wherever we see x, we replace it with x plus delta x. Expanding this bracket, we are going to have is going to be x plus delta x in two places, and that is going to result to x squared plus 2x delta x plus delta x squared, and this is still equal to y plus delta y. Now we subtract y from both sides, and we got that y from the beginning is equal to x squared. So subtracting y from this side, we have y plus delta y minus y, and this is going to be x squared plus 2x delta x plus delta x squared, then minus, we are subtracting y from here, and we'll be subtracting the equivalent of y from this side, and that is going to be x squared. This y is going to go with this y, this is going to go with this, so we left with delta y to be equal to 2x delta x plus delta x squared. Now the next thing we do is we divide both sides by delta x. So we divide this side by delta x, and we divide this side also by delta x. This is going to go with this, and this is going to take out one out of these two, so we'll be left with delta x there. In that case, delta y over delta x will be equal to 2x plus delta x. From here we have delta y over delta x to be equal to 2x plus delta x, and we record that as delta y approach 0, delta x will also approach 0, and delta y over delta x will approach dy over dx. We derived this in our last video, so you might want to watch that video. The link will be displayed at the end of this video. So in that case, delta y over delta x, as it approaches dy over dx, is going to be 2x, and this will also approach 0. That means this is going to be replaced with 0. Therefore, dy over dx is now equal to 2x. In that case, the derivative of the function y to be equal to x squared is equal to 2x. The second example we'll be looking at is we'll be finding the derivative of a function of y to be equal to 4x cubed. And the first thing we do, just like in the last example, we introduce delta y to the left hand side, and we introduce delta x to the right hand side. So here we are going to have y plus delta y to be equal to, is going to be 4, and our x is going to be x plus delta x, then raised to the power of 3. So before we proceed, let us find the output of this expression of x plus delta x raised to the power of 3. From our binomial theorem, we know that if we have an expression like this, the coefficient of the output is going to be 1, 3, 3, and 1. So this is going to be x raised to the power of 3. Then we are going to have 3x squared delta x plus 3x delta x squared plus delta x cube. We can see that as the index of x is reducing, here we have x cube, here we have x squared. As the coefficient of x is reducing, the coefficient of delta x is increasing. In that case, we can simply replace x plus delta x raised to the power of 3 with all of this. That means this is going to be, we have y plus delta y to be equal to 4, everything to, we have x cube plus 3x squared delta x plus 3x delta x squared plus delta x cube. So expanding this bracket, we have this is going to be 4x cube plus this is going to be 4 times 3 is going to give us 12x squared delta x plus 4 times 3 is going to give us 12x delta x squared plus this is going to give us 4 delta x cube, and this is still the same as y plus delta y. Now subtracting y and its corresponding value from the other side, we have y plus delta y minus y to be equal to 4x cube plus 12x squared delta x plus 12x delta x squared plus 4 delta x cube, then minus the value of y, which is 4x cube. This is going to cancel out this, and this is going to cancel out this. So we'll be left with delta y here, and this is going to be 12x squared delta x plus 12x delta x squared plus 4 delta x cube. Now dividing both sides by delta x, we divide this side by delta x, and we also divide all of this by delta x. Since delta x is common to the numerator, so that means this is going to cancel out this. This will take out 1 from this, is going to remain 1, and this is going to take out 1 from this, so this is going to remain 2. So that means we have delta y over delta x to be equal to 12x squared plus 12x delta x plus 4 delta x squared. Now as delta x approaches 0, delta y over delta x approach dy over dx. So that means we have dy over dx to be equal to 12x squared, then plus 12x multiplied by delta x is going to become 0 plus 4 delta x is going to become 0 here squared. So all of this is going to become 0. That means dy over dx is going to be 12x squared. This is going to become 0 and this is going to become 0. In that case, given a function of y to be equal to 4x cubed, the derivative of that function is going to give us 12x squared. Another example we'll be looking at is we'll be finding, using the first principle, the derivative of the function of y to be equal to x raised to the power of 1 over 2. Given y to be a function of x, just as usual, we introduce delta y and delta x accordingly. So here we have y plus delta y to be equal to, this is going to be x plus delta x, everything raised to the power of 1 over 2. This x plus delta x raised to the power of 1 over 2 is to equivalent to the square root of x plus delta x. So that means y plus delta y is the same as the square root of x plus delta x. Now subtracting y from both sides, we are going to have y plus delta y minus y to be equal to the square root of x plus delta x, and we recall that our y is the same as x raised to the power of 1 over 2, which is the same as the square root of x. This is going to cancel out this, and we'll be left with delta y, which is equal to the square root of x plus delta x minus the square root of x. Dividing both sides by delta x, we're going to have delta y over delta x, and we have this also divided by delta x. From here, how do we resolve this fraction? To resolve this fraction, we are going to multiply both the numerator and the denominator by the conjugate of this numerator, and therefore we are going to multiply this by square root of x plus delta x, and going by conjugate, if this is negative, then this is going to be positive. So we have all over the square root of x plus delta x, then plus the square root of x. This is equal to, in multiplying these two numerators, we are going to arrive at the difference of two squares. And going by difference of two squares, we have x squared minus y squared. That means the factor of these terms is going to be x minus y, x plus y, from difference of two squares. And this is synonymous to these two expressions. We have x minus y, this is the same as our x, and this is the same as our y, and this is the same as x plus y. So this is synonymous to difference of two squares. That means we can simply replace these two with taking this as our x and taking this as our y. That means we can say this is the same as square root of x plus delta x squared, then minus square root of x squared. So everything divided by the product of the denominator is going to give us delta x multiplied by square root of x plus delta x plus delta x. So this is still the same as delta y over delta x. From here, this squared can cancel out this square root. This square can also cancel out this square root, and therefore we'll be left with delta y over delta x to be equal to x plus delta x minus x, everything divided by delta x into square root of x plus delta x, then plus the square root of x. So this is going to cancel out this x minus x, so we'll be left with delta y over delta x to be equal to delta x all over delta x into square root of x plus delta x, then plus square root of x. So this is going to cancel this also. Therefore, we'll be left with delta y over delta x is equal to 1 over square root of x plus delta x plus the square root of x. Now, as delta x approaches 0, delta y over delta x approach dy over dx. In that case, this is going to turn to dy over dx. Therefore, we are going to have 1 over the square root of x plus delta x is going to become 0 plus square root of x. Therefore, dy over dx is going to be 1 over square root of x plus the square root of x. Therefore, dy over dx is going to give us 1 over 2 root x. That means if we are given y to be x raised to power 1 over 2, which is the same as square root of x, then the derivative of that function is going to be 1 over 2 square root of x. The last example we'll be considering is given y to be 1 over x, we want to find the derivative of this function. So just like other examples, we are going to introduce delta y and delta x to both sides. So we have y plus delta y, and that is going to be equal to 1 over x plus delta x. Subtracting y from both sides, we have y plus delta y minus y, which is equal to 1 over x plus delta x, and we know that the value of y is equal to 1 over x. This is going to cancel this, and we'll be left with delta y in this side. So we are going to have 1 over x plus delta x minus 1 over x. To simplify this expression, we are going to have x plus delta x then multiplied by x as our LCM, the common denominator, and let's write this out here. We have x plus delta x multiplied by x. If we multiply this fraction with this, our common denominator, this is going to cancel this, and therefore we'll be left with x. So that means we'll be left with x here minus. If we also multiply this with this x is going to cancel this, therefore we'll be left with this. So that means we are going to have x plus delta x here. In other words, delta y is going to be x minus delta x all over x plus delta x then multiplied by x. So that means we have delta y to be equal to this x is going to cancel this and be left with negative delta x. So that means we have negative delta x here all over x plus delta x then multiplied by x. Now dividing both sides by delta x, we are going to have delta y over delta x to be equal to negative delta x all over x plus delta x multiplied by x then multiplied by delta x, which is the same as this. So this is going to cancel this, and that means we'll be left with negative 1 up here. So that means delta y over delta x is equal to minus 1 all over x plus delta x multiplied by x. Now we call that as delta x approach 0, delta y over delta x approach dy over dx. Now dy over dx is going to be equal to negative 1 all over x plus our dx is going to become 0 just as this becomes this. So we're going to have 0 here and we have x here. That means dy over dx, which is the derivative of our function, is going to be negative 1 all over x plus 0 is going to become x multiplied by x. That is going to give us x squared, which is the derivative of our function. That means if y is given as 1 over x, then the derivative of our function is going to be negative 1 over x squared. If we consider a few of our examples, in the first example we have y to be equal to x squared, and the derivative of our function was gotten to be 2x. In the second example, we have y to be equal to 4x cubed, and the derivative of our function was 12x squared. In the third example, we have y to be equal to x raised to the power of 1 over 2, which is the same as square root of x, and the derivative of our function was 1 over 2 root x. In the last example we just did, we have y to be equal to 1 over x, and the derivative of our function was negative 1 over x squared. Now if we look at the pattern of these functions and their derivatives, from where we can see that if we are given an expression of y to be x raised to a constant, then the derivative of that function is going to give us n x raised to the power of n minus 1. Just as we see here, we have 2 here, so the 2 comes to this side and the resulting index is the former index minus 1. If we also look at this, we have 4x cubed. That means if we are given an expression of y to be the product of a constant and x raised to another constant, the derivative of that function is going to be the product of the index and the coefficient. That is going to be n multiplied by a x raised to the power of n minus 1. These two general expressions can be easily used to get the derivative of any function. For example, if we are given y to be x cubed, using this general expression, then our dy over dx, which is the derivative of our function, is going to be, this is going to come down just as this, so we are going to have 3x then raised to the power of 3 minus 1, which is going to give us 3x squared. If we are given an expression of y to be equal to 6x raised to the power of 4, so this is going to give us, just as we have here, the index is multiplying the coefficient here, so that means we are going to multiply this by this, which is going to give us 24x raised to the power of 4 minus 1, and that is going to give us 24x cubed. So these two general formulas can be used to easily find the derivative of any function. If you want to read more about the topics covered so far on this channel and more, visit easymathsandsecret.com, scroll to the math section and click on any topic you would like to read about. Don't forget to subscribe to this channel and give your reaction in the comment section below. If you like this video, you can also give it a thumbs up. I will see you in the next video.